Good evening. Good evening. There we go. Well, it's great to be back here. 30 years we've been working together with Oracle. I remember just graduating from 6th grade when they started together. It's awesome to be back here. Thank you. Slowly, slowly. All right. You know, one of the challenges I have when I get really excited about a topic I'm going to cover is I tend to, what the production crew calls, I go off-roading, which means what I'm talking about has nothing to do with the slide behind me because I forget to click. So if that happens, just kind of roll with it, be casual about it. If you're a little more buttoned down, a little uptight, you can lightly raise your hand, I'll call on you, and we'll work together to get back on track. All right, so let's get going. I'm pleased to represent Intel tonight and talk about what we're doing in this environment. You know, well-established industries are in the midst of a big and major transformation. Transformation of one industry is having an impact on other industries. The catalyst for this transformation is one tiny little thing.
It's more abundant than sand, more powerful than any source of energy, invisible to the naked eye, yet packed with the potential to impact almost every aspect of our lives. It is data. And it's the unseen force behind the next great wave of the technology revolution, driving innovation in cloud computing, autonomous driving, artificial intelligence, virtual and augmented reality, 5G, and more. And as the development of world-changing innovations continue to accelerate the pace of change at work, home, and everywhere in between, it may not always be clear where the future of technology is going, but it is clear where that future begins.
Data in this century is like oil was to the last century. But there's one big difference. Oil is a finite resource, and data is the ultimate renewable resource. It's impacting every aspect of our lives. How we work, how we live, how we play, and how we communicate. Every aspect. And that data is massive. By 2020, they predict there'll be 44 zettabytes of data in this digital universe. 5 years after that, they expect it to go to 180 zettabytes of data, all being driven by smart and connected devices. 20 to 30 billion connected devices in just 3 years. You know, I look at my own home, and I have a large number of connected devices already, so it's happening. And these are connected to each other, but they're connected to the cloud. And that's why I'm here tonight to talk to you about that and how that data is going to the cloud. That data is not static. It is in motion, going from these devices through the network to the cloud where innovation is happening. And that innovation is what is driving business transformation. Industries across the globe are being impacted, and they're transforming. Financial services have a broad set of data they collect, and they're using artificial intelligence to increase and improve their modeling, their financial algorithms, to deliver better value to their customers. How many of you have been called by a credit card company to say there's been some unusual activity? Financial services are using machine learning to actually investigate what's going on. And then blockchain is absolutely impacting this digital, transparent technology for economic transactions is happening today, and financial services are moving forward with that. The transportation industry has been impacted greatly. You take a modern aircraft And it's going to generate 40,000 gigabytes of data per day. 40,000 gigabytes from the engines and sensors on that plane. And that data is going to be in motion, and it's going to be computed on, and value is going to be generated. Aircraft component suppliers are now turning from that to services companies, delivering better value to the aircraft industry. How many are anxious for autonomous driving? If you have young kids, you're very anxious for autonomous driving. Intel has taken a leadership role in this. All the assets we bring to bear, including our recent acquisition of Mobileye. We believe that an autonomous vehicle will generate 4,000 gigabytes of data per day. 4,000 gigabytes. Cameras, GPS, radar, LiDAR, sonar, all these sensors collecting data, communicating that data to other automobiles into the data center to extract value, training, inference, all sorts of value and services to the automotive industry. We also wanted to commission a study, so we did, to understand the impacts of what happens when we move to an autonomous driving community. And what we discovered is something very unique. There will be 250 million hours of idle time. You don't have to drive. 250 million hours of idle time. What are people going to do during that idle time? We know what your kids are going to do. Or social media. But they're going to consume data. They're going to generate data. And that virtuous cycle is going to continue. The other impact is the creation of an economy. We call it the passenger economy. And we see this growing by 2050 to $7 trillion. Imagine the services and capabilities that are going to be delivered to that autonomous driving environment, building a whole new economy because of this transformation. Anybody use the VR environment? I tell you, that's an immersive experience. It's crazy to experience that. All that information coming and extracting value. We're continuing to advance our technology, 4i7, 4i9, having VR-ready platforms to give that best experience. We're working on Flygate to detail the head-mount display. All these things we're driving for that personal, private consumption, gaming and entertainment. But we see that expanding to the commercial space. Real estate, government, retail, all sorts of commercial environments are going to take advantage of that data and transform their businesses. And one that's really close to my heart is sports. I love this season. I'm a huge football fan. I grew up a Niners fan. I stood on the stage several years ago with Jerry Rice, and we talked about what big data is going to do to that sport. How wearables and other types of sensors are going to collect a big amount of data. They're going to analyze that data. And that data is going to be used to what? Enhance the performance of that athlete and help that coach train the athlete. This has continued to a broad set of sports, global-wide. And I thought, wow, who else is working on this? We found this company called Perform Group out of the UK that's taken advantage of this business transformation and advancing that technology for the sports recruiter and fan alike. Let's take a look at what they're doing. Pretty amazing stuff, and I thought instead of myself talking about it, I'd invite the head of big data, Juan Zakara, to come out and talk to us about what they're doing at Perform Group. Come on out, Juan. Saw the video. Amazing stuff. Tell us what you're doing with that data.
Yeah, amazing stuff. Well, you saw a little bit about how data is used around the sports. I think that all here, we've all seen Moneyball and how analyzing player stats changed the way players are recruited and how the fans interact with the game. We are now all aware that websites and are now dedicated to research, analytics, and player statistics. This goes further down the line, now with the Internet of Things, real-time analytics, with wearables in sensors and tracking data. So it's all that happens right now in the field in sports.
Do you agree that this data and analyzing this data is driving efficiency in sports as well as recruiting?
Yes, absolutely. Analyzing sports movements has implications all through sports. Imagine you are a recruiter and you are analyzing the data, and the data is accurate. You can select the best players that fit the best model of your sports club. If you are a manager of a team, you can define the strategy. You can analyze the data live, real time, receive the data, and change your strategy live through the game. You can also give this data back to specialists and analyze the fitness of your players, and analyze and go through the information of your players, and even detect if they can go to a scenario of getting injured or something like that.
What's changed? What's changed in the technology to make this?
Well, that's a sort of a combination of three main things. First of all, there's a tremendous amount of data. We are now analyzing on the scale of the petabyte. And we have data to analyze in terms of video. We analyze event data of the video itself. We have sensors, we have wearables, we have tracking cameras. And we mash up this with historical data, and we analyze the evolution of a player, of a team, of a model of play, and all through it. We, second of all, we analyze and we create modeling over the data. We analyze with machine learning technologies, with deep learning technologies, with all artificial intelligence nuances available for us. And also very important is the type of platforms. They need to be flawless. They need to be important. It's very important for us to have the latest and most advanced technologies out of Intel servers and Oracle databases, which can manage our data and leverage the best insights for us through the business. And so we are looking forward now for the next generation of Oracle processors and Oracle systems based on Intel Xeon scalable processors.
Excellent. Thank you very much.
You.
I appreciate you all. Thank you
you
very much. So, great. So it's clear. Billions of smart and connected devices communicating to the cloud. Innovations happening, driving business transformation. There's something missing. Something is necessary to make this happen. That is technology transformation, and why I'm talking to you today. The technology has to transition in order to support that mass amount of data in motion. You take a look at the data trends. 180 zettabytes of data, that's not too far away, and it's going to continue to grow. So they got to improve the bandwidth of the network. If you look forward to 2021, not far away, they said 70% of the data will be mobile video. 70% of the data on the network will be mobile video. And what's that look like? 1 second at a time. 1 second, there will be 1 million minutes of video going across the network. 1 second, 1 million minutes of video going across the network. Things have to change in that network. They have to enhance the broadband. How many of you have been in a really cool event and you try to take a picture and send it to social media? I was just recently, went to this really cool event. I'm walking through, lots of people doing all these post pictures, and Nicole Kidman walks by. What would you do, right? I pop my selfie. I want to put it up on social media because I want to be liked, because I'm really cool. Didn't happen. All I got was a circle, right? Never posted, so they get liked. They need to fix that broadband when a lot of devices are struggling for the same bandwidth. Ultra low latency. We have these usage models, like autonomous driving. You want that data fast. And then finally, you're going to see usage models with machine-to-machine. Inventory management is a great example where you want to personalize that inventory for your customers and be able to have that machine-to-machine communication to locate that inventory and put it where it belongs quickly is going to be very important. So there's no better time than now to transform to 5G. And Intel is going to be at the heart of that transformation with our Intel Xeon platform, right at the heart. As you transform that network software-defined network and network function virtualization, we are going to build the most optimized platform to help drive that transformation. We also need to work in the open source community to help accelerate that transformation. We're platinum sponsors of Linux Foundation and working on things like OPNFV, which takes open source projects like OpenStack, OpenVSwitch, KVM, and brings them together, integrates and tests those, making them ready for network function virtualization infrastructure. And then we go further with ONAP, or ONAP. And this is the creation, orchestration, and lifecycle capabilities to deploy those in your infrastructure. So we're working together with the industry, with our platform technology, and also with software to accelerate this transformation. Now, there's no other industry that I can think of than the communication services industries that are going through this transformation in a very aggressive way. Companies like AT&T. And that's why I'm pleased to bring on stage Melissa Arnaldi, Senior Executive Vice President of AT&T. Melissa, come on out.
Thank you.
Hi, Melissa, good to see you again.
Yes, you too. You did talk about sports today, football. I don't know if your team's won or not. I'm just going to tell you, I am in remorse right now because the Cowboys lost. I was so sad. But that's okay, they'll come back if you're a Cowboys fan.
My college team did win.
Okay, all right, good.
Yeah. Stanford beat Arizona State. Any Stanford fan? So, the network, the transformation is happening. Why don't you give us a little bit of a landscape of what's going on?
Yeah, sure. So it's interesting just hearing you talk, Doug. So essentially what you talked about, that's our story. I mean, think about open source, NFV, virtualization, 5G, that's AT&T. So a couple of things, though, when you think about our next network, it has exploded over the last several years. When you think about what's happened over the last 10 years, we've seen an increase of over 250,000% of volume on our network. I mean, that's huge, right? That's nothing to take lightly. And so with that, it takes a capital investment, and that's really why we had to go on this journey with you guys around, how do you virtualize a network? How do you get the cost down? So by 2020, we expect the increase on our network will be 10x what we've seen the last 10 years.
You're on this
10x.
journey. You're on this journey.
Yep.
Where are you at?
Okay, well, interesting. So 3 years ago, we talked about becoming a software-defined networking, supporting virtualization and VNF. So I'm proud to say we started that 3 years ago. By the end of this year, we'll have 55% of our critical network functions will be virtualized on our network. 55%. And by 2020, we'll have 75%. So we are on the way. We're going to have a tipping point in this year, which is going to be great success.
And I'm excited to say you've been working with us, which is great.
Yes.
That's how that's worked out.
Yeah, so, Doug, you guys really are a strategic partner for us. We've worked together for over the last 10 years, but the last 12 to 18 months, I think, have been really special because we've embarked on this strategic partnership around having a data-centric, software-defined network. And in particular, we work a lot with your Xeon product for the microprocessor. That has been key for us. It's easy to deploy, it's scalable, it's fast, so that's going to be key for us in the future as well.
There's another partner you're working with who happens to be putting on this conference, Oracle.
Yeah.
What's going on with that?
Yeah, so again, another strategic partnership for us. When you think about the data we've talked about, when you look at AT&T, we have thousands of applications, not hundreds, but thousands. So with those applications also come thousands of databases. And so if we want to scale, we want to be fast, we want to have flexibility, it's all about speed and agility for our clients. We've got to get out of those siloed, monolithic applications and databases. So we have an agreement now that we signed in May with Oracle, which is great. It's going to take hundreds of thousands of our databases to the cloud. It's going to be an Oracle private cloud. It's going to really give us the efficiency that we need.
That's fantastic. All right. A lot of fans out there.
That's good.
What's next?
Well, we've got a lot of things on our plate, but I have to tell you, we're going to continue to focus on our strategy around network virtualization. We now have focused on unleashing the data that we have. We have over 168 petabytes of data that comes across our network. Then you look at all the data we have internally with our applications. it's exploding. So we're going to capitalize on that data. We're going to make sure we have access to the data. We can treat our customers when and where they want to be treated, how they want to be treated, what products and services they want. That's key. The other thing that is pivotal for us is 5G, as you talked about. And, Intel's a key partner for us. We've done several now 5G trials, particularly on the fixed wireless, and it's been a great partnership. We're going to learn along the way, but I think our strategic partnership is going to be critical for that.
Fantastic. That's awesome. We're looking forward to the continued collaboration.
Yep, absolutely.
Thank you so much, Melissa. She basically gave the last half of my keynote. She talked about what we need to do. Because all that data is going to come to the computing environment. All that work that Melissa and AT&T are doing is going to drive more demand on the cloud and enterprise environment. And so there's going to be requirements to accept that demand and drive through that demand and deliver innovation to drive that business transformation. Melissa mentioned it. Scalability, flexibility, and expandability are critical for us to address in this ever-expanding world where data is driving this transformation. That's why we're so excited about the Intel Xeon Scalable platform we just recently launched. It is an amazing platform. It's the industry's biggest platform advancement in a decade. That's saying a lot coming out of Intel. It's the biggest transformation in a decade. And how do we do that? First of all, we continue that trend of average performance improvement by 1.65x on a broad set of workloads. In this platform, we did it by incorporating 28 cores and an SoC and doubling the PCIe and memory bandwidth in that platform, driving that performance. We've been talking a lot about data. There's going to be a desire to secure that data, so we want to make sure we drive performance optimization in our platform to give you the ability to secure that data. We've added instructions like AES-NI and AVX 512. These are instructions to help accelerate things like encryption and decryption. Those same technologies can be applied to the cryptographic hashing that you see in blockchain, making certain that our platform is the best platform for blockchain execution. We started working collaboratively with Oracle on blockchain technology and how they can apply it to their services. I'm super excited about an announcement that should be coming in the next few days around the space, so pay attention to what we're doing with Oracle around blockchain. And then finally, the agility. The ability to move VMs. We've been investing in VM technology and VT technology for over a decade in order to decrease latency in moving workloads. If you take a look at a 4-year-old server compared to today's generation server, you'll see 4.2x improvement in VM workload throughput. 4.2x. This is driving total cost of ownership down by 65%, the value we want to bring to the industry. We've continued our work with Oracle on what I announced on this stage several years ago called Project Apollo, taking that Intel Xeon Scalable platform and Oracle's enterprise software working together to optimize those solutions, finding areas where we can drive better performance, better value, better capabilities for our customers. We've already achieved some amazing results from generation to generation of our platform, improving the number of cloud users by 2.3x. Again, that value goes right to you in your environment, taking advantage of that performance work we do together. So that Intel Xeon Scalable platform is the cornerstone of the work we're doing. And I thought it'd be great to bring out the head of Oracle's cloud infrastructure and talk about how they're utilizing that in the environment. So bring out Clash from Oracle. Cash, come on out. Hey, Cash. How are you? Good to see you.
Good to see you. Hello. Welcome to Oracle OpenWorld. So let me start by talking about what we are hearing from our customers. Our customers are telling us that they have some really important decisions to make about their applications, about their databases, about their infrastructure. Should they go for a SaaS-based model? Should they lift and shift their applications and move them over to a cloud infrastructure? Should they adopt cloud-native strategies, rewrite their applications, have a hybrid model? These are really, really important decisions. And most importantly, they're also trying to drive the cost down. So what we are doing here from an Oracle Cloud infrastructure, we are providing the most robust infrastructure for our customers, highest level of reliability across multiple availability domains across our regions. We are providing scale and elasticity across millions of cores. Why? Because our customers' demands may change. We're also providing the highest level of performance across our robust network for all the applications. We are providing a security and governance models that our enterprises need but are not getting from the existing other cloud options. And we're doing all of that in conjunction with Intel while driving the cost down. So you can come to our environment, Oracle Cloud Infrastructure, spin up a bare metal server running Intel processor with the highest density, get access to the fastest storage, get access to Exadata services, right? With just simple clicks or CLI or any simple way you want to access our infrastructure. And we can't do this alone. We have to join hands with our partners like Intel. Leveraging Intel's latest technologies, we are able to offer our customers choices about their applications that they want to bring to our platform, whether they be big data, traditional IT, or cloud native. So I really look forward to the collaboration, building the next generation infrastructure where customers can bring their present and grow their future. Thank you.
Fantastic. Thank you so much, Cash. Thank you. So we're addressing scalability with our Xeon platform. But I know a lot of you out there get demands on unique workloads to accelerate those workloads quickly and drive better value for your end users. And that's where flexibility comes in. And that's why we're excited about Intel's family of FPGAs, the Stratix 10 and the Aria 10. This family of high-performance, low-power FPGAs are critical to driving and optimizing that environment for high-bandwidth workloads that you need to accelerate. We're equally as excited about the launch of our latest acceleration stack for Intel CPUs and Intel FPGAs. This is the world's first common user interface. So what's that mean? It gives you consistency across your development environment. It gives you the tools and diagnostics capabilities to do what? To deploy that solution much quicker and have code reuse that you demand. And we're already seeing solutions hit the market. Pattern recognition, compression, analytics, encryption, decryption, utilizing this in conjunction with the Xeon platform, accelerating those workloads. You know, 70% of traffic on the network goes east to west. Server to server, behind the firewall, 70% of the traffic. And I know a lot of you need to secure that data. And so having encryption is going to be critical. This is one of the use cases we're working together with Oracle on to understand how we can do that and accelerate that capability to encrypt that data. So what we've done is taken our Aria 10 FPGA and combined it with the Ethernet controller, the XL710. And we put that together in a package. And this is going to be used to experiment. It's a pathfinding capability that we're utilizing with our partners, including Oracle, to figure out how we can accelerate IPsec traffic and encryption across that network. And you can see Andy Nelson's reaction to this effort, the value that they can bring in that infrastructure Cash just talked about, in that Oracle Cloud infrastructure, the value they can bring. So we have a saying at Intel, if I can bring David up, we call it risk-taking. It's one of our core values, is risk-taking. And so I'm going to take a little bit of a risk, and we're going to actually run this pathfinding workload on this device and show you what it looks like. We also say that if it doesn't work, it's called informed risk-taking, but we'll see how this goes. So on my right, your left, is the throughput on our CPU with no encryption. On the left, you're going to see that throughput being measured, but this time fully encrypting that data. Now what you should see is amazing. See nothing, no change. What's that mean? we're able to fully encrypt that data without impacting that service level agreement, that value you're bringing to your customers. You're not impacting them, but yet you're encrypting that data. This is the kind of innovation we're driving together, taking advantage of that flexibility we deliver in our FPGAs. Thank you, David. Thank you. All right. And then finally, expandability. That ability to address all that data I've been talking about, massive amount of data. Zettabytes, we talked about, it's going to continue to grow. Here's the data temperature spectrum, showing how that data goes from hot, warm to cold. We've been investing in technology to bring that data closer, increase the capacity, increase the speed. One of the technologies is our investment in Intel 3D NAND technology to increase the capacity and lower the cost. We are now shipping what we call our Intel SSD for the data center products, utilizing this technology. This is the latest version of our Intel 3D SSD NAND. This NAND generation increased capacity by 2x, at the same time lowered power by 45%. 2x capacity increase, 45% less power. I'm also just as excited to announce that Oracle is committed to shipping this in their next generation engineered systems and that Oracle cloud infrastructure you heard from Patch. So they're going to be utilizing that product. The other innovation is on form factor. This is a form factor innovation, taking that same 3D NAND SSD technology and putting in it, I know, stand by, the ruler. So where we got the name. This is our ruler form factor. And what this is designed for is to drive that density up in the server, getting more and more storage in that server. We announced this last month, and we're going to be shipping it at the end of this year. By the end of 2018, you'll be able to utilize this form factor and put up to 1 petabyte of data storage in a 1U rack. 1 petabyte using this form factor. So that's amazing advancement. Now, the next technology that we're investing in, we would argue, and we have, that this is the biggest transformation in memory and media in the past 26 years. 3D XPoint. It's going to bring up to 10x the density of DRAM. Applying this into an SSD, another family member of the SSD family, we're able, over a traditional NAND SSD, increase performance up to 8x. Up to 8x performance, 60 times better quality of service, and reduce latency up to 40 times with this technology. This product is shipping now. Amazing advancement utilizing 3D XPoint. Now, our CEO stood up on stage a couple years ago and said, we want to go further, and we want to take this technology and drive it even closer to the processor in a DIMM form factor. And that's what we have right here. We call this our Intel Persistent Memory. And this is bringing large-scale memory for data-hungry applications closer to that CPU. Now, this is extremely complex technology. I know it looks really simple because it's in a standard form factor you see all the time. It's not. It's an amazing technology advancement, the biggest in generations. So it's supposed to be talking about this. I would love to bring out the experts in this area. From Intel Vice President Alper, come on stage, and from Oracle Senior Vice President Juan Lueza. Come on out, guys. Hey, Alper. Juan, good to see you.
No, bueno, pero acá están
Hey,
cosas
we need to
importantes.
switch you guys because we need to label you properly.
All right. I go like that? Perfect.
I don't want to get you confused.
That's right. Branding.
Yeah. All right, so this is amazing stuff. You know, I'm not the technical giant on this. I want you guys to talk about the advancements. We talked about this on stage several years ago. What's happened since then?
Doug, I'm really excited for Intel to be back at the show and talk about the progress we've made with the Intel Persistent Memory technology. Tonight, we will be showcasing 2 different systems running actual Oracle workloads So that's going to be super exciting for us. And from the very early mechanical samples we share here to today, being able to run real, actual enterprise workloads is a great milestone for us. And throughout our journey, Oracle has been a great partner, great collaborator, and an early adopter of our technology.
And Juan, we worked together on a lot of projects through our careers. You have to be excited about what we're doing here.
The 3D crosspoint technology is definitely really exciting.
But by the way, for Juan, that is super exciting.
No, it's true. I mean, if you look at computers, the fundamental ingredients, processors, memory, disk, network, you know, we added flash like a decade ago. It's very rare that a new ingredient gets added to it. And this is one of those few times. It only happens once a decade, once every 2 decades. So non-volatile memory is a very big deal. And that's why we've been working at Oracle very closely with Intel for the last 4 years. Our architects have been working together to ensure that this works really well for databases. And we have specific features that we work together to add specifically for the Oracle and other databases.
Fantastic.
Well, this is a great segue into our first demo. As we are pushing more and more data closer to the CPU, implementing such high capacity with DRAM only can be cost prohibitive, or not at all possible due to the limitations of their technology. So tonight, Juan and I will show you how the Intel persistent memory technology will change all of that.
Has this ever been shown before?
Well, I don't
Okay, it's it.
All right, let's go. This is a live demo, by the way. We're running it in real time. What you're seeing here is we're running queries into a 3 terabyte data set using Oracle's in-memory database. We have 2 systems running here. The first one in the lower section here we're showing is a DRAM only. It has 1.5 terabytes of DRAM. The second system is exactly the same with another 1.5 terabytes of Intel persistent memory DIMMs attached to it. As you can see, the baseline system, because it wasn't able to accommodate the entire data set, the data was split between the DRAM and the SSD storage, and you're seeing the performance difference between these 2 implementations. Of course, just a larger capacity is not what makes this solution so much interesting. It's also what Oracle has done with the software innovation here. Juan?
Yeah, so we've been working for many years now on in-memory technologies inside the database. We put in a lot of optimizations for it. And actually now we put in a lot of optimizations specifically for non-volatile memory. So in fact, the software that we're shipping today already has many algorithms that we've already built specifically to be ready for this technology. So when it ships, the database software is going to be ready. And it makes a big difference. You can see this. This makes a big difference. Performance still makes a big difference for customers. And the reason is because it's been shown many times that interaction time makes a huge difference to users, and that translates to more sales. So customers want immediate answers, and they want immediate action. And this kind of technology makes it possible, and accelerates it for the future.
Exactly. In-memory makes all of this possible. And we're really excited to work with Oracle to make all of this happen together.
Okay, so this fast insight you're talking about, I mentioned earlier that there's challenges with fraud and theft of data these days. How does this help?
Well, it helps in a lot of ways. So fraud is all about catching things in real time. So when someone's trying to make a transaction, make a purchase, you have to do a lot of analysis to figure out who is this person? You know, what's their buying pattern? Where do they buy things? So you can figure out, hey, is this a valid transaction or is it a fraudulent transaction? And so there's more and more computation has to be put into real time to compute this. And so this kind of technology where you can get data and process it extremely quickly makes a giant difference in stopping fraud.
All right, now for our second demo, and I know, Juan, you've been really excited about this for some time. For the first time tonight, we'll be demoing an Oracle Exadata engineered system with Intel persistent memory DIMMs inside. We had never done this before, again, another first for us. And what we're showing in these dials is actually an Exadata system with the Exadata software running enhanced by the Intel persistent memory DIMMs. And you're seeing our development test environment reporting in the latency and the IOPS associated with the operations we're doing. The static needles that you're seeing in black are the performance levels of our baseline systems that do not contain this technology here. So let's go through it. Oh, you're already running, wonderful. So you're already seeing tremendous IOPS increases here. And it's all made possible by the significantly improved latency characteristics of our memory technology.
Yeah, so Exadata, it's been on the market almost 10 years, and everyone knows it's the fastest, most available, best platform for running Oracle database. And we put every performance optimization that's ever been invented into Exadata. And so now we're going to bring the non-volatile memory technology to it, and that's going to accelerate even more. And one of the things we're very excited about is that with data in memory, we can do something called remote direct memory access. That means we can access the memory directly in another server without going through software. So it eliminates the whole software stack from the remote access, which is going to accelerate things even beyond just the use of the non-volatile memory. It enables this new architecture for accessing data that's dramatically faster than what we've ever had.
Oh, it's just so cool.
Yes, very much.
All right, this is amazing stuff, guys. I really appreciate you coming out here and helping me understand, as well as everybody else, what we're doing this year.
Thanks, Doug.
Thank you so much. Now, this is amazing new technology. New technology, as you heard Juan say, takes time and collaboration. Intel's persistent memory will be available along with the refresh of our current Xeon scalable platform. Intel and Oracle are committed to continue to optimize these solutions so they're ready for that launch of the product. I talked about mass number, billions of devices collecting data, driving that through the network, computing on that to drive innovation, which in turn drives that business transformation. And what was missing was the technology transformation I talked about today. So I'll leave you with the thought that was started with in the video. It may not always be clear where the future of technology is going, but it is clear where the future begins. And it begins with data. Thank you.